Hello everyone. In this video, let us see Gauss Jordan method. This is nothing but the extension of Gauss elimination method. So basically in Gauss elimination method, we will try to reduce to the row echelon form. Here only the diagonal elements are going to be non-zero in the augmented matrix. So 2, 4, 9, right? In those places only you will get the values, and the other values we'll try to make it as 0. And then eventually you can compare the right hand side values. So it is same as Gauss elimination as I said. So we'll be writing the augmented matrix. What are the coefficient? First row 2, 1, 3. And colon 1 which is there on the right hand side. Second row 4, 4, 7, and then right hand side we have 1. Third row 2, 5, 9, and right hand side we have 3. So we've written the augmented matrix. Now first step will be the same as the Gauss elimination method. That is, we are going to make the values below 2 as 0. That is 4 and 2. Because in the first diagonal element is 2, right? So that should be non-zero. Below that I'm trying to make the other values 0. And it is nothing but R2 is 4, right? So 4 minus 2 into 2 we'll write. Right? R2 goes to R2 minus 2 R1. Okay. So, and then R3 goes to R3 minus R1. So 2 minus 2, 0. And we are fixing row 1 here and changing the values in row 2 and row 3. So your augmented matrix will become, first element is 2 and then 1, 3, 1. So we are writing the first row, and then the second row values 4 minus 2 into 2. If you want you can write in rough, which is 0. Then 4 minus 2 into 1, that is 4 minus 2, which is 2. Then 7 minus 2 into 3, which is 7 minus 6, 1. And last value 1 minus 2 into 1, that is 1 minus 1 minus 1. Now last row R3 goes to R3 minus R1. So 2 minus 2, 0. 5 minus 1, 4. 9 minus 3, we have 6. 3 minus 1, we have 2. So now what we are going to do is, we will fix the row 2 here, and we will try to make the element below row 2 and above row 2. That's exactly the above the diagonal and below the diagonal of second row. We'll make it 0. That is 4 and 1. That is my target. So I'm going to fix R2. So using R2, I'm going to make the element which is below the diagonal and above the diagonal of that row 2 as 0. So since I am going to fix R2, first you write R2 to avoid confusion. And then you are going to make the 4 as 0, right? So what you will do? R3 goes to, and then R1 goes to. This is how we are going to write. Okay. So first R1 goes to 2 into R1, because 1 is there. 1 into 2 minus 2. So 2 into R1 minus 2, R2. Okay. So why I have written 2 R1? First value is 1, the first circle. So 1 into 2 minus. And the next one is R3 minus 2 R2. So R3 is 4 minus 2 into 2. So you will get 0. Again, try to write down all the values in some rough paper and then enter the values. And you will get the values as So 2 into 2 minus 0, 1 into 2 minus 2, 3 into 2 minus 1. So we will get the first row values as 2 into 2 minus 0. So what you will get 4. The next one is 1 into 2 minus 2. So you will get 0. That is our target. Next is 3 into 2, which is 6 minus 1, 5. And then 1 into 2 minus 1. So which is nothing but plus 1. So you will eventually get 3. 2 plus 1, 3. So now we will see R3 values. R3 minus 2, R2 we'll try. So first write down the values of R3. So 0 minus 2 into 2 and 4 minus 2 into 1, and then 6 minus 2 into 4 minus 2 into 2, 6 minus 2 into 1, and 2 minus 2 into minus 1. Just check whether we have written the values correctly. And then first one will become 2 minus 2 into 0, 0. Second one 4 minus 4, 0. Then third one 6 minus 2, 4. And the last one 2 minus a minus plus 2, 4. So this is our target. If you see the last row, completely we've reached the target because your last row has 0, 0, 4. Only the diagonal element is alive. So you make that value as 1. So it's easy for our calculations. So you can keep it as 4. So 0 to 1. And then last row I'm dividing it by 4. Because that last value, the diagonal value is 4. So if I divide it by 4, I will get 1. What is the final answer? The Z answer? Z we have got, that is 1. Now our target is the one that marked, I have 5 and that 1. That I have make it as 0. So now I'm going to fix R3, and with the help of R3, I'm going to make these two values 0, 5 and 1. So since I'm fixing R3, I'm going to change R1 as, if you see 5 times if I multiply, it is correct, right? So R1 minus 5 times R3, because R3 has only 1. It's easy for calculation. That's why we divided last row by 4. And R2 goes to R2 minus how many times? Only 1, right? So directly R2 minus R3. So we will write the augmented matrix. The last row we'll write as it is. And when we implement this R1 minus 5 R3, so R1, what are the values? 4. 4 minus 5 into 0, which is 4. And then 0 minus 5 into 0, which is 0. Then 5 minus 5 into 1, which is nothing but 5 minus 5, 0. So our target is achieved. And 3 minus 5 into 1, which is 3 minus 5, nothing but minus 2. Similarly, write down the values for R2. We get the first value as 0, second value is 2, third value is 0, and minus 2. So finally, if we see the diagonal elements are only there present here, all the other values are 0, that is 4 to 1 are diagonal. So 4x plus 0y plus 0z is minus 2. So 4x is minus 2, which implies x is minus 2 by 4, which is nothing but minus 1 by 2. Then 2y is minus 2 from the second row. And then z is equal to 1. So this is how we solve. So if I simplify the first one, minus 1 by 2 as I told. The second one, y is minus 1 and z is 1. So direct comparison. Normally in Gauss elimination, we'll take z first and then substitute in second equation. And of course, I have written x, y, z. In the question, they have given x1, x2, x3. So let me change it as the same constant. So we will check in one of the equation, the first equation itself. I'll check 2 into minus 1 by 2, whether our answer is right or wrong. If we simplify, we are getting minus 1 plus 1 plus 3. So 3 minus 2, which is 1. What is your first equation right hand side? 1. Correct? So we got it. So hence our solution is correct. So basically it's like Gauss elimination, but here um, the last one will be the diagonal values, and same as Gauss elimination, we'll fix R1 first, and then after that using R2 we will change the values in R1 and R3. Finally R3 will be in form. Using R3 we will change R1 and R2, so that only the diagonal elements will be present in it. So direct comparison of the values, and always check whether your answer is right or wrong.